Making an inference. So today what we're going to do is we're going to learn one more piece of analysis that will allow us to make our inference, because we need to have some confidence in our analysis and in our ability to answer the question properly, right? Are girls really smarter than boys? Well, let's see, okay? So what we're going to do is we're going to look today at what's called the ICI, which stands for Informal Confidence Interval. So this is just a calculation that you will not have to do, even though when we're walking through the lesson at Education Perfect, they're going to make a big deal about how it's found. You will not have to do it. NZ Grapher will do it for you, including the numbers at the beginning and the end that you will need. Your job is to make sure that you understand what it means and how to describe it. Okay? And to do that, again, we're just going to look at some more. You're going to build that word template that you have. Remember that we don't want you to say things exactly the way they do, but I do want you to be aware that you must have some key words. And today I'm going to show you how exactly I'm going to be grading this paper, so you can make sure that you know you've written enough or too little. And we're going to go back and look at some key words. I've been trying to point them out as we go. Been underlining them in the sentences, but we'll see. All right, so let's just go to our Education Perfect and look through the lesson. So after the completing of this lesson, you're going to be able to describe the informal confidence interval. Okay? So what is it saying? You're going to identify how the effect that sample size has on the accuracy. So we'll talk a little bit about sample size again. And then finally, you're going to be able to make an inference based on that interval. So this is where you're going to be able to answer your question. Okay? All right. So let's just go through some of these. So we've been talking about taking a sample and then comparing those median values from the sample as well as some other analysis points from the sample. But if you think about it, every sample you take is going to be different, yes? And so you can assume that you're going to get different values each time you take a sample. If you don't use the entire population, then you're going to get some variability. And it's actually called sampling variability. And we've talked about that in some of our other papers. You had to have that phrase. And that is a phrase I will be looking for when we do those. And you'll see it in the sentences when we get to the sentences. So say, for example, here we have a set of data. If we take a sample of this, you see the population mean, that means the mean for the entire sample is 14.5. Then they took a sample, which gives a median, median of 18. And then they took a second sample, which has a median of 9. So you see there's a great deal of variability in those numbers, right? One of them, the median was very high, the other was pretty low. And so we need to make sure that we can be confident that no matter what sample we take, our inference is still valid. Because if you just do it once, it really doesn't tell you much. Yeah? Okay? Have you ever had to start a question and then later changed your mind? Kind of the same way. Mm-hmm.
Are we using random number generated for this assessment?
No, the numbers will be given to you. The samples, you'll choose the samples from actual data. Okay? All right. So we're going to use what's called the informal confidence interval to be able to make our decision. And you do not have to worry about this calculation. I don't need to see it anywhere because NZ Grapher will do the math for you. So you don't have to use this formula or make it work, but I just want to talk a little bit about it. You have the sample median plus or minus 1.5 times the IQR. You may remember what IQR stands for? Interquartile range, good. Divided by the square root of n, where n is simply the number of pieces of your sample. Okay? So it's just a formula that statisticians derived to give you some idea to kind of level the field for dealing with sampling variability. It is not an absolute. That's why it's an informal confidence interval, but it does give you a good idea of whether your median would fit in the median for the data that you're working with. Okay? All right. And you can be fairly confident. That's another phrase I'm going to be looking for that you'll see in the sentences we talk about. So you don't need to worry about it now, but you need to be aware. You cannot say, I am confident, right? This is an informal confidence interval. It is, you are fairly confident. I can be fairly confident. There is no time in stats, almost no time in stats, that you can say girls are smarter than boys, right? You need to say, based on my data, I can be fairly confident that boys are dumber than girls or whatever, okay? So make sure you're very careful with your language if you do change the languages of the language of the sentence, okay? We also will be talking about the population and that the population median should lie within that ICI. Again, don't worry about building your own sentence right now. We're going to look at a sentence that has all of that in it and talk about it. But what I want to focus on, though, is that you need to make sure that some key words appear. I'm going to have a sentence that I'm looking for, and that in that sentence I'm going to be looking for some keywords. All right? So we're only going to take one sample, but then NZ Grapher is going to resample that same data set over and over and over again to be, or actually it's not, if I forgot, that's the other one. Never mind, you're not year 13. So NZ Grapher is going to use that formula to be able to find the informal confidence interval based on that sample. Okay? So it will do the math for you. You don't have to. Right? Now, the bigger the sample is, the bigger the number is that you divide by, okay, then the smaller the sampling is going to be, the confidence interval is going to be. Now that makes perfect sense if you think about it. If you divide an 8 by a 2, what do you get? A 4. But if you divide an 8 by a 4, what do you get? 2. So the bigger the number is on the bottom that you're dividing by, the smaller the answer is. Does that make sense? Okay. Which means that it'll narrow down. The bigger the sample, the more compact that range will be for your estimate. Okay? Meaning it'll be more precise. Right? Because you could just say, well, there's a range of this, huge range. Yeah, you're telling the truth, but the more you can narrow it down, the better. And the way to narrow it down is use a bigger sample size. So we said that the minimum sample size is what? 30. But you could do better and do more, depending on the size of your data. Now, don't use the whole population, but choose a sample size that is big enough. So 50 or 60 might be nice, right? It gives you a better. But then be prepared when we talked about when we were doing our random sampling. You must be prepared to say why you chose a sample of that size. I think a sample of 60 would be better, and why. Okay? All right. So here we go. Here we have a population. We have a sample, and we have our population. Let's see what happens with our interquartile range. Now, so here we have our interquartile range. This data is very symmetrical, right? We don't have our mean dot to tell us if it's skewed one way or another, but it doesn't look very skewed, right? Maybe a tiny skew to the left, but I doubt it. Now, and again, the way you will check is to see if the mean dot is further one way or another, right? Do not assume just because there's a few, because this looks a little longer than this one, right? There's a few points down here. You can't assume that it's skewed. This one looks very symmetrical, right? Just harking back to something else. So here we go. You're going to get your informal confidence interval. It's going to be a little blue line right in the middle. It's going to go across your median, right? And you're going to see that the population median here is included in the length of that blue line. So that means that this range does include the population median, which means that you can be pretty certain that that you can write a conclusion based on your sample. Okay, and we'll talk again about how to exactly to write that in just a moment. Okay. All right. So here we go. We have 10 different samples, and you'll see that for all of these samples, except for 2 of them, the population median is inside the confidence interval. But here and here it's not. But look at what our sample size is. The sample size in this case is 30. But if we use the same exact data and we increase the sample size to 100, every single one of these blue lines contains the red line. So do you see that increasing the sample size will increase your accuracy? Because you could get a strange sample and then take the informal confidence interval and get this one down here, the second one from the bottom there, and your conclusion would be probably wrong. Because if you pick a bigger sample, you can see that your conclusion should be that yes, the median is contained in that spread, right? So be careful. If you choose a too small a sample size based on the population of data you have, then you could make a wrong inference. So make it as large as possible. So even though the minimum is 30, I would use at least 50, maybe even use 100. Who knows? It's going to be up to you. Right? So here we go. We have 2. Set A contains 50 data points. Set B contains 200 data points. Which one will have the smaller ICI? A or B? B. Why? B is correct. No. B is correct. But why? What have I stood up here for 10 minutes telling you? Yeah, but what about it? The bigger the sample, the smaller your confidence interval, but the more you can be sure that it's going to happen. Okay? Guys, come on. All right? So do you see that here it's more compact because we have a smaller confidence interval, but that means that it's more likely to be correct.
Could you just say that again about the bigger
The larger the sample, the better your informal confidence interval will be.
I have all that written down.
Okay? All right. So again, you don't have to calculate it, but you do need to be aware of how to describe it. Okay? So let's talk about how we're going to make an inference based on that. So you're going to do some questions with the informal confidence interval. So you're going to do that through NZ Grapher. So make sure that you know that we'll talk about how to make sure. It's just clicking 2 buttons. We talked about those when we looked at NZ Grapher. You're going to click in ICI and make sure to click on the boundaries, because you cannot talk about anything in this paper without talking about the numbers. If you just give a statement, yes, you'll get an achieved, but if you don't do the numbers, you can't get a merit. Or anything better, of course. Okay? All right. So we need to talk about these things. That the informal confidence interval allows for sampling variability. Right? That the sample is representative of the population, so the population median should lie in that ICI. And we'll see the actual sentences in just a moment. And finally, what does the ICI mean in context of the investigation? My median is this, therefore I can conclude that girls are smarter than boys. Right? Okay? So let's look at these. So here we have our 2 values. And we'll just look at the sentence. An ICI allows for sampling variability. Not negotiable. Have to have that. If you don't have that sentence, then your analysis is garbage. So I am confident. So you're writing the confident. So you can say I am confident, or I can be confident, something like that. That the medians. Yeah, I don't like that I am confident. I would be comfortable saying I can be confident, or I can be fairly confident, right? Okay. That the medians of any further samples will lie within these respective ICIs. Okay, well that statement you can be confident about, because look at the statement they're making. You can be confident they're going to be within the ICI, right? Which makes you fairly confident that you can make your statement. So that one you can say confident. Do you see the difference? Because the formula tells you that it's got to. Does that make sense? So it will lie within that area.
What if you still say I'm fairly confident? Will you get marked down
You should just say confident.
for that?
Yeah, for that. These samples are representative of the populations they come from. See, they're referring back to the population. Every time you do one of these, it refers back to what's happening in the population. You're using a sample to refer back to the population. So I am confident that the population medians also lie within these ICIs. Again, perfectly fine to say confident here, because we're talking about the mathematical formula that says you can be confident based on your numbers. Yes? As long as you use a large enough sample. But if you use a small sample, it's just going to get bigger and bigger. So to try to take up for the fact that you use too small a sample. All right? Therefore, I am confident that the median lung capacity is between blah, blah, blah. Now, these numbers are coming straight from the informal confidence interval. It's actually from this one, because we're talking about for running. So you see these two numbers right there? Those are your boundaries for your informal confidence interval, and that's what you're going to use as the numbers to reinforce your findings. And that one's for runners, and then you have another one for swimmers among male year 13 students. So that's what we're talking about in context. So put the numbers in and make sure you refer back to the context of your graph. Who had what? Okay? Now, here's the thing. They always do this little breakdown. So look at these. This is what I'm going to use to grade your paper. You will discuss how sampling variability. I'm confident that the medians for any further samples will lie within these respective ICIs. That's your achieved. Okay? Then I'm going to look for this sentence. These samples are representative for the populations they come from, so I'm confident that the population... that's still unachieved too. Sorry. Okay? Then, therefore, I am achieved the median lung capacity is between... Here's the numbers, and here's the context. The numbers and the context, that's your merit / excellence, depending on, are your numbers correct? And how well you said you describe the populations you're measuring, right? If you say just for runners and for swimmers, but then you forget the male 13 students, then still could get a merit, but you're not going to get an excellence, right? So do you see how it's going to work? The plain statements without any numbers or context, those are the things you're going to get for achieved. You'll put the numbers in, that's your merit. You put the numbers in context, that's the excellence. So you see how it's going to work? Now, when you're doing these achieved, there are certain key words that I'm going to be looking for. And for this particular one, I'm going to be looking for sampling variability. Okay? I'm going to be looking for that you're talking about the medians. You know that it's the medians you're dealing with. Okay? And that they're representatives of the population. Right? So you can be confident about it. So I'm going to be looking for a few key words in each one. I'll have a list of the key words. And we've been underlining those as we went. So hopefully you've got this done. We'll talk about it when we revise too. So don't panic if you haven't. All right? Now, let's look at the last thing they do. So that will allow you to write in your little sentences. So it's 4 sentences. The first 2 are very formulaic. You can copy and paste those, write the way just the way they are. It would be nice if you changed a little bit to just kind of use your own words, but don't forget, don't change them so much that you're missing your keywords or you're saying something that doesn't exist. Okay? The other thing, and then finally you're writing it in context of the investigation. That's the last sentence. So very straightforward. Okay. And again, NZ Grapher is going to do all the math for you. So we're going to practice a few of those, and then we're going to use, after the bell, we're going to use the second part. We're going to begin talking about our conclusion. Because the sooner we're through with this, the sooner we're through with the lesson parts of this, we can move on to a practice. And what we'll do is we'll just do the same practice with the same values so that we all know that we're on the right page. Okay? And then I'll find out when our test is going to be.